Well, it's a pleasure to be here with you all. And I'm going to be talking a little bit about an overview of applications of hydrogen. So some of this material we've seen before, but I'm really going to be taking a different focus on it. Um, so just a brief background. I am my background is in education and entrepreneurship. My day job is I am starting a new sustainability-focused industrial gas company, and and I am here talking to you today, mostly in my capacity as an educator. I am a creator of a program called the New Hydrogen Economy, which is hosted by Terra.do, and maybe we'll share a little bit more about that later. But today, in terms of what I want to cover today, I want to kind of share with you a little bit of perspective on why hydrogen has on sort of a key driver of all the recent enthusiasm about hydrogen, and that is sort of like when you zoom out and you look at 2050 and like, or it's at some kind of net zero future scenario, and ask like, how do we get there? Like, how do we decarbonize all of these different human activities? It turns out that hydrogen has a very large role, or many think tanks and smart people who kind of like sketch out what that future might look like. There's kind of an emerging consensus that hydrogen has a really important role to play. And I want to kind of draw a sketch of what that future might look like. And that's kind of what I want to cover with my time. So this is less directly applicable to what's happening today or tomorrow. But hopefully it helps round out your picture of like, why is there all this enthusiasm, and like, where is this road going? So um, uh, so this is a graphic from a report by the Energy Transitions Commission, and it is sort of like an illustration of what does the entire energy system, what is all the energy that we use globally, what does that look like? How do we generate that energy, and how do we use it for which sectors? So like, these are all the different things that we're using energy for along here on the right. And what I want you to take away from this graph is that hydrogen and related fuels constitute about 15% of final energy. So this is a gigantic component of how of the energy system. If this comes true, hydrogen today is a tiny share of the energy system. So. So the future that we are talking about when we're talking about hydrogen's role in the energy transition is one where hydrogen is one of those foundational technologies like wind or solar that are the major building blocks of how we decarbonize. So that's kind of just and that's obviously very hypothetical. No one really knows what the future will look like. But if you want to understand why there is so much present day hype and enthusiasm, I think it's because people are trying to figure out how we get to a net zero future, and it's hard to answer that question without having a whole lot of hydrogen in the mix. So I want to walk through this diagram kind of shows, this is called a Sankey diagram, this with all these funny lines everywhere. This diagram kind of shows where this hydrogen feeds in, some in transport, some in industrial uses, some in buildings and heating. And we're going to go through that in the next 10 minutes or so, and just kind of give you kind of a rough picture of like, where does hydrogen fit into our energy system? And so we'll start with, we're going to cover 4 sectors: industry, transport, power, and buildings. And these are in the order of importance, the order of size, roughly, of like how much hydrogen, where is all this hydrogen going, is going roughly in this order of sectors. We'll start with industry. I would summarize that there are kind of 3 industrial applications. One of them is a feedstock for chemicals. So you take the hydrogen molecule and you make it into a different molecule. And that's largely ammonia and refining. And obviously in a net zero future, there would be a lot less refining going on. But And then we have steel. Hydrogen is a key element of a new steel process. I would say most popular net zero fuel technology that we're seeing deployment for. And then finally, the third industrial application is industrial process heat. So when you need very high, very high temperature industrial heat to cook a bunch of rocks into cement, then it's hard to do that with electricity. And hydrogen is one of the possible sources of, one of the possible routes to decarbonization. And so here's a graph that shows kind of on the bottom here. This is sort of like all the hydrogen that would be required in order to power that net zero graph that we saw earlier. And this is all the hydrogen that is a part of that these industrial applications that I just described. And as you can see, this is a big chunk of all the hydrogen. So about a third of the hydrogen that would be globally produced in this net zero 2050 scenario would be used for chemicals, feedstock for chemicals, for steel, and for industrial process heat. And that covers the industry sector. We're going to talk a little bit about transport. So this is also a very significant component of decarbonization. This is another third or so. One thing I want to call out is that light duty transport, which is kind of a big thing that you hear about if you go and Google, like, what are we using all hydrogen for? People will talk about fuel cell cars, but I would say also that there is kind of an emerging consensus that batteries are going to be much more important than hydrogen for light duty transport, and that may even be true for heavy duty transport, although there's a better fit for hydrogen. Basically, the reason to use hydrogen is that it carries more energy per unit of weight than a battery would. And this becomes especially important when you get to shipping and aviation. So there's no way to cruise across the ocean with 13,000 containers on battery power. There's not that many batteries in the world, and they would sink the ship. It's too heavy. So really for ship, and same story for transatlantic flights. So for shipping and aviation, there's sort of no one has, I would say it's very difficult to power those operations without molecular fuels. Molecular fuels are very energy dense relative to batteries, and so that's a major part of how hydrogen fits into the transportation sector. You might notice that these are different colors. This is actually hydrogen packaged up in an ammonia molecule, and this is for the aviation application, has hydrogen packaged up in some kind of carbon carrying fuel. So those are more complicated topics that we don't have time to get into here, but the takeaway that I want you to have is that when people talk about hydrogen, they are also kind of talking about like upgraded molecules that start with green hydrogen that have more favorable properties. And that's a part of the enthusiasm for hydrogen, is that it's sort of this very useful building block for molecular fuels. I'm going to skip this. So that's all that I wanted to cover about transport. Power is the applications within the power sector are the most complex, and I want to spend the most of my time in this sector because I think it's really worth understanding. So what you can see here is that power looks like a very small and not that large a sector here, and ETC has hydrogen powering about 2% of total power demand, but actually, as we'll see in the next couple slides, the story is much larger and more complicated than that. So when we look into how hydrogen interacts with the power sector, with the grid, you see sort of this forest of overlapping use cases. And we're going to go through these one by one. So the most simple and straightforward way to understand hydrogen's interaction with the power grid is thinking about hydrogen as a kind of weird battery. You take electricity, you turn it into hydrogen, and then when you need electricity again at a later time, you turn the hydrogen back into electricity with a fuel cell or by setting fire to the hydrogen and powering a turbine. And hydrogen's properties as a battery are that it is very inefficient. It is kind of expensive, but it is one of the only ways, one of the only cheap. When you start trying to store incredible amounts of energy or trying to store energy to power to derive continuous power for days on end, if you need a battery that can offer that kind of performance characteristics, it's really one of the only viable options aside from pumped hydro. And there are other emerging possibilities that are arguably better than hydrogen. But when we think about hydrogen as a straightforward storage, electricity storage technology, that's what we're talking about. It's sort of an inefficient battery that you can run for days, whereas most lithium-ion batteries, for instance, you can just hold about a few hours of power. But actually, hydrogen's role in storing power is a little bit more complicated and interesting than that. Often you hear about hydrogen being useful because it can make use of the make better use of variable renewable electricity. And actually, I think this is an important part of hydrogen's story. So, gosh, I need to redo this slide. Bear with me through this confusing slide. Sometimes you will hear the story about how you might know that we are wasting a fair amount of renewable electricity already. I live in a state in a state, California, that has a lot of variable electricity on the grid, and I think in a recent month there was over 10% curtailment, which is a fancy word for we just threw the energy away. We just threw it on the ground. It's sort of like there was too much sun and we didn't need all that power, and so we just wasted it. And sometimes you might hear about the idea that you can make hydrogen out of just this curtailment, and that's actually not feasible for kind of complicated reasons. But hydrogen plays really well with variable renewable electricity. It can help make this. It can help use this curtailment and also other renewable electricity, and help make better use of this power. While electrolysis electrolyzers can run at a 60 to 80% capacity factor, 60 to 80% of the time, and still be very economically viable. And what this does is it's a part of the grid equation that helps keep the grid balanced and helps kind of drive demand for new variable renewable electricity. So hydrogen has this really healthy synergy with a kind of with variable renewable electricity, it's an area of impact that I'd encourage any of you energy wonks to look into a little bit more. And so in that sense, I want to kind of make an analogy that actually all electrolytic hydrogen is energy storage, and all of it, if you produce all this hydrogen that's in all of these sectors from electricity, in some sense it's all energy storage, it's all power storage, and it's a way to make something useful out of energy that happens at the wrong time of day. And so this is just a different way of thinking about it. But when you think about power storage, hydrogen is sort of this weird sector spanning storage machine. Anyway, moving on, the rest of this is more straightforward. Hydrogen is one of the only green sources of firm dispatchable power. So Los Angeles recently had to make plans to replace its last coal plant, and they have a pretty aggressive decarbonization timeline. And I want to talk about their story as a kind of as a case study. So they took this coal plant and they replaced it with a 800 megawatt gas turbine. And today that turbine, or at time of operation, that turbine will mostly be powered by fossil gas and about 30% by hydrogen. And then by the time their decarbonization timeline hits, which I think is 2035, it will be powered by 100% green hydrogen. And the interesting thing about this power plant is that it's located on top of this geographic formation that makes it very cheap to store incredible amounts of hydrogen. You could store terawatts of hydrogen in this geological formation, and so what this allows LA to do is, they need to be able to power the grid when the sun isn't shining, or when the sun is shining too high and everyone's got their AC on, which is a thing in LA. And hydrogen is a part of how they can do that. Yeah. And the next topic that I want to touch on, and I think Zane covered this briefly as well. Hydrogen creates a way for countries to import and export net zero energy. So, so here I have a story that is about Saudi Arabia sending blue ammonia to Japan, which is actually not renewable electricity. It's net zero electricity. Yes, okay, arguably net zero electricity. So countries with a surplus of energy that want to export it can do so using hydrogen or ammonia, which is kind of like hydrogen zipped up in an easier to ship molecule. And Japan is one of those countries that, if Japan had to power itself on renewable electricity alone, it would just, or on like wind and solar alone, it would have a very difficult time doing that just geographically. And so many, and Europe as well is expecting to need to import a lot of hydrogen for different applications. So hydrogen is like a useful way for countries with a surplus of net zero energy, of especially renewable energy, to make money off of it and power the decarbonization of other countries. And the final set of applications within the power sector is backup and mobile power. So microgrids, off-grid applications like mining, data centers. There's a lot of relatively small applications, but still quite large, still multi-billion-dollar applications. And I think I want to mention that these applications are going to be especially important during these like early expensive years of hydrogen. A lot of these are actually drawing a lot of investment and kind of paving the pathway for these larger scale applications within the power sector. And that's it. That's the material that I wanted to cover together. And look at that, right to the minute.